So I guess we can proceed, right? Okay, before we proceed, we all got the idea of the we all got the can you also my screen, first of all?
No, it's just your screen is not showing. Just your face, like your camera.
Okay. Let me apologize about that. Okay. And now?
Yeah, yeah,
Yes, we can see it a little bit. Yeah.
Okay. Let me get it. Okay. So before we proceed, do we all understand the concept of gradient descent and the learning rate stuff? Do we all understand it now?
yeah. Like it was very self-explanatory. Like I've made attempts at learning like grabbing like what's gradient descent is, but like today, like the way you explained it, everything, yeah, I do. It's perfect.
Okay, that's nice. So okay, I'm glad I was able to be of help. Okay, I haven't run this notebook. I also upload my Kaggle API.
Especially, I mean, I'm just chatting, though. There was something you
Sure, sure,
said
sure,
to
sure.
me. You said something about like when you're watching videos on YouTube and you're reading articles too. You usually hear
Mhm.
PhD people talk about like loss function, cost function, and sometimes they use it interchangeably. But today, for the first
Mhm.
time, because of you, I now know the difference between cost function, loss function. So
Mhm.
thanks for that one too. Thanks.
But the thing is, I think in practice also, most people use it in like interchangeably as well. So, but the major thing is just like once you understand what exactly is going on, whatever it is being called, you understand like um the concept. So that's majorly once you understand the concept. If any, so and since it's sometimes can be confusing, my call loss function, cost function. But regardless, you know exactly what is wrong. So and then depending on the context that the person is also like talking about. So you can know if the person is just talking about a singular data point, or the person is talking about, a whole feature. Excuse me. The person is talking about a singular data point, or the person is talking about the whole feature of a data set. So you understand. So the major thing is understand what exactly is going on. Once you know what is going on, all these things won't be an issue. Okay. So okay, let's go to uh, thanks for the feedback, by the way. I really appreciate that. Okay, so we talked about the concept of gradient descent and learning rate earlier in the so please ensure you interact with the notebook. Read it through. There might be something that we didn't like explain in class. There's still a lot of things that needs to be done, which we couldn't do due to time. So please interact with it. If you have any query, let us know. Uh, oh, this thing they upload. Sorry, I'm trying to run the notebook. Okay. So this should work now. Yeah. Okay. Okay. This I won't want to go much into this because of time. I won't want to go much into all this into this experiment that our tutor was going through. So I want everyone to like go through it or in in our free time afterwards, go through it and see what exactly is trying to communicate here. So what I want us to do, what I want us to do is go through the go through it as a as a project, build a like starting from the data set and then building a linear regression like from there. So I think I should. I'm not sure I included this in my data set. Maybe. Okay. Okay. So now, as we were saying before we left for the break, let's build. We're trying to build a logistic regression. Yeah, was that? Okay. Okay. No, okay. So still down. Okay. Yes. Okay. Okay. Now, okay. I think I don't need to explain this part. So this is just like using pandas to build our data set. And this I already spoke about this area. I also spoke about this data set of info. So okay, after checking the info now, and then you've also checked you've also checked the data type of the data set, and you see that they are all in the data type that you're expected. Price, which is expected as an integer, is not like we are not is not being represented as an object. So at this point, if we say that the data type is incorrect, we have to fix it at this point. Or else instead of if price is being seen as an object or as a string, when we are passing it through our model, it will be seeing it as a string. So it won't see it as a number, as a string. So which is why we need to do all this. We have to check. So, and when you just run, if you just see its number and you run it and you pass it through your model, you will run it into error. So you need to know why we are doing this. So and we can see we have like 500 as we already from here we said that we have 545 like we have 545 rows. And looking here and I say that non-null counts, which is like it means that they are not null, which is they have real values. All of them are 545. So since I already checked this and I see that all of them are like they are not null, they are very okay. I think I can just proceed. But I'm doing this in case of our data sets. Everybody will be using working with data sets. This data set is a very clean one. That is why I'm getting this. If not, I will have like okay. So okay, first off, okay, as aside this now, I want to check if my aside this, I want to check if my data set is duplicated. Like if any row is appearing twice. So which is why I am doing this. So is there any duplicated row in my data set? It said no. So if there is any if I am getting false here, then I can now proceed to get the number of duplicated rows. See the number of the sum of the duplicated rows. See the sum of it is giving me 0. So adding I have duplicated rows. The first thing I do is what I drop the number of duplicated rows. So I know that all the rows in my data set is what unique. If having repeated rows is just like it just it is uncalled for. It just introduces whatever is it just introduces noise and introduces it's just not good. It's not good for our data. It introduces noise to our model. So if it is necessary, we just like get rid of it. The first thing you do is get rid of it. So If you still, so if you after you did this and you now say, oh, I have duplicated data sets, the next thing you do is like you drop it. After seeing the number of duplicated rows, then you drop it. This in place, so no, this in place equals to saying that I'm dropping it in. I want you to drop it, and I also want you to return the remaining data sets. That is what this in place equals true. That's what it's telling us. Drop those duplicated data sets and return the rest of the original data sets. Is that clear enough?
Yes, yes, yes.
Okay. So then after that, I tried to check is null dot sum. Which this null is telling me is this one is checking if I have an empty row, if I have any empty row, if there is any row that have a null value. If there's any row that has a null value, it will return it to me and it will sum it. So okay, this column now for price column, is there any null value there? So as you can see, I checked everything. There is no null value in it. So there's no null value in it. If I have a null value, hmm, I think we already spoke on it. What are the approaches I can what are the method I can do to to you know to mitigate my null values? We already talked about it when we were talking about introduction, when we were introducing data science. Does anybody on the call remember?
Sorry, I didn't get that question. Sorry.
I said checking our data set, checking our column, we can say that there is no null value in our data sets, right? But I am asking now, if we have a null value in our data sets, what are the techniques to mitigate it in our data set?
I mean, depending on the, I
Drop.
mean, that's
You can use the method drop now. I think if you want to, that's if you want to drop the null value.
Okay, you can drop it. Yes,
Yeah.
that is one. Mhm.
Then you can also like fill it up depending on like, for example, if you have like extreme like values like outliers,
Mhm.
maybe you want to fill it with like you want to fill it up with like the median, like instead of doing something like a mean that might like affect the data set.
Mm, no, you were on point. You were on point, though. The thing is, you were on point, but I think you got it mixed up at some point. So the thing is, when you have null values, it depends on the null value that you have. Don't get it. Don't get it. Don't get it twisted. If the column, if it is a like if it is a categorical column, so there are different ways to do it. You can either so there are different techniques. It depends on the use case now. You can feel you can feel based on the mean, you can feel based on the median, I can feel based on the mode. It depends on your use case. So there is no absolute way of feeling it. But before you drop a date, before you drop or probably a row or a column in a data set, you need to like evaluate it very well before you decide that you want to drop it. If you're having missing value in a particular column, okay, let's say in this price, let's say in this price now, I'm having let's say I'm having 70% of the values in this price column is let's say 70% of this price column is what is not 70% is not I'm not saying that I'm not saying like just the 100. If it is 100, it depends on the value of the data set. We're talking about the percentage. If the percentage set. If around if once more than 50 or once more than 50% of the data of a particular column is null, you need to evaluate it. Is it worth keeping or not? Like since it's once the null value of the null is so, then in that case you can decide to like drop it. But once it's already reaching like 70% null value, there is absolutely nothing you can get from it. So you just like drop that column. There's no that's the best solution to it. It is, or you go, is either you drop that column or you go and find probably that data is missing, then you can find ways to like get that data. If you can find the means of getting that data, fine. But if there is no means of getting that data, it is just best to let it. But if you're having a um having a in if aside from having a lot of missing values, you can fill with mean, you can fill with median, and you can fill with mode. You can always try. It depends on your use case, and it also depends on what you are trying to achieve. So you can always experiment with it and see whichever works best for your use case. There's also something we call fill forward and fill backward. So we that the fill forward now is majorly used, especially in you are doing time series. If you be able to like cover time series in this what. So if you are doing time series now. So time series. If you are okay, let's say you are doing forecasting. Let's say you are doing a let's say stock prediction, weather forecasting. Those stocks are they are time, they are time. How would I say it now? They are very sensitive to time. I don't, but I don't forget what I'm trying to say. They are very much dependent on time. So, and what you are predicting is you want to predict probably the next few seconds. You want to predict the next few seconds. So, if you are predicting the next few seconds, and probably some feature of the next few seconds is unavailable, will you the best thing is just like you want your model to see what you won't want it to see the future, you won't want it to peep into the future. So you fill it with um it can be probably the last data set now. Let's say for column okay, let me come to this place now. Can you see my cursor?
Yes, yes.
So let's say this is a time series. Let's say this is a time series prediction, and we have 2 year, and probably instead of 4 year, this value is missing. We have a null value here. What we can do is that with instead of just like instead of dropping it, we can decide and probably doing mean median. We can just feed this 4. I want to predict this. Want to predict this row, right? So we can just fill this instead since we have nothing here, can just feed it with 2. Exactly. We won't feed it not these 2. Okay, let me use this row. So if this particular is missing, so we'll fill it. I want to predict this particular row. Okay, the model has seen this first row, it has seen the second row. It wants to predict the third row. Hmm? Mind you, the model has not been exposed to this row 4 and row 5. So want to predict row 3. So what we will do is that if this is missing, we'll just fill this instead of since we have null here, we'll fill it with this 4. Do you get?
Yes, yes. I feel.
Are we all on the same page? Do we all get, or should I come again?
I mean, if anybody, I think it's fine. To me.
Izu is not the only one on the call, please. I want to know if we get that, or should I come again?
Please come again.
Okay, okay. I think let me do.
So I will say you should come again because the something is like somehow I'm not getting it, sir.
Please talk. Okay, you know what? Let me do this. I want to open a new tab. I'm not sure. I'm not sure. Let me check if I can. Let me check if I can get a. Okay. Let me browse forward view. Forward view in machine learning. Okay. Okay. Can you see this? Can you see this part? Let,
Yes, sir,
let
we can
me
see
let
it.
me
Yes,
Yes, sir, we
yes,
can
we
see it,
can.
sir.
let me click on it. Okay. Okay. So okay. This is it. Forward fill and backward fill are simple. Okay. Okay. So it said that it propagates the last known value forward until the next non-missing value. Do you get? So like, let me come back. This is the for this particular column now. For this particular column, this is the last known value. This one is the missing value. Hmm? But want to predict it. So we just this is the last known value. We'll just like assume that okay, this is still 4. So that's we'll just assume like this is still 4. So it will just like forward fill. As I was saying, we don't use this when we are doing tabular data set. It's only advisable to use that when we are doing a time series. Let me see if they wrote anything about it. Should carry forward. So and for backward fill, instead of the last one, like we just like get. Let me see. Let's see. Okay, I think they didn't talk about the use case. But when we do use it is when we are doing time series, but we're not doing time series. I just wanted to explain the various methods of filling missing value. So you fill it with the last. Is it okay? Okay. Because the reason why we are filling it with 4 and not with this is the missing value. We are filling it with 4 and not 3. Why? Because this is a different feature. This is a feature on its own. This is a different feature. Hope that is not confusing.
No, it's not
Bedroom is
confusing.
a different.
No, 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 it's not confusing. It's not confusing.
Bedroom, bathroom is a different feature. If this one is missing, so this is a totally different feature. There is is standing on its own. This is standing on its own. If we have this, if I'm doing a forward, you mean that okay, for the last known value will be the next value, and if I'm doing backward fill, these two will fill this. So that's it. But majorly, if we are doing stuff like this, if we are working with tabular data set like this, you majorly work with and mean and median are majorly what I think so far what I do use that majorly works well for me. It's either mean or median. So the thing is, you can build your model and compare. Okay, when you use median how was your model performance? When you use mode, how was your model performance? And you also read on this. You can this thing. You can also read. You can read on Medium post like, okay, when to use median, when to use mode. So you will see different perspective of people that have written about it. But from when you read about all these stuff, it helps you like it helps you like have your own like perspective. It helps you have your own like sense of direction of what works. So whenever you are doing it, you can say that okay, I'm doing this because this in your experience, this is what works for you. I hope that is clear. Is that clear?
Yeah, yeah, that's clear.
Okay. So I guess I guess you understood this aspect now. So now I want to check the number of I want to check the number of unique values in my um data set. So let's look carefully at my data set. Okay. In coming to this in main road, guest through basement, and okay, in 1, 2, 3, 4, 5, how many unique value in this main road, guest room, basement, hot water heating, air conditioning, and preferred area? How many unique value are we supposed to be expecting?
Two, two each.
To each.
Two unique
So
values.
let's two unique values. Correct. So we have 1, 2, 3. We have main. Okay, that is main road. Okay, let's check. Let's check. Okay, which one is the first one? Main road. Main road. How many unique values does main road has? It has two. I guess that is correct. Guest room and basement, 2, 2. Guest room, guest room and basement, 2, 2. Then we have hot water heating and air conditioning. Hot water heating and air conditioning. So then prefer area. So let me tell you a reason why we are checking. If you the reason why I checked it in this furnishing status, it is furnished semi for I think it has three. I think it is three. Yeah, it is three. Furnished, semi furnished, and non furnished. The reason why we are checking this is for you to know. The thing is this as Python, as you know, Python is case sensitive. Hmm? Yes. Is different from yes, and it's also different from yes. Do you get that? So if one of these even as it is telling me I have two unique values, if I add yes and I add yes and I add this yes all in the same column, it will give me the unique values of this one. So these are three different unique values. Are we following? These are three unique values. So it will tell so if as I'm checking now to see that okay, how many unique values I'm expecting two unique values, and I got two unique values. So that means we are safe. This function status I'm expecting three, I got three. Parking, parking is a numerical value. So this parking is a numerical value, so I might have more. This price and area, these ones are unique numerical values. So and we are not like we are not sectioning them. So this you can have as many unique values as possible. So that is the reason why this main road, guest room, basement, also water heating and air conditioning, and also as well as this preferred area. I have to like be sure that they are actually two. If they are not two, then I have to like normalize them. So I have to now decide though, Okay, after checking them, is it what exactly I will now have to check the values of the unique values. Hmm? I'll have to check them. I'll have to check them and see, okay, let me I think I'm not sure. I hope this works too. Okay. There, okay. Okay. Let me do give string. Okay. Can you see this? Can we all see this?
Yes, yes.
So I already
Yes.
so since it is two, since I already see it is two. So if I am getting much more than that, then I can now check what are the unique values for each of my column, the ones that are not giving me the correct answer. And I can now check the values they are having. So if I am having more, so if I'm having this yes, I'm having this yes, I'm having this yes. So I'll now have to like decide. So I'll now say, okay, I want to convert everything to I will now make them uniform. Okay, all of this one, I want to convert it to this years, or I want to convert it to this years, or this. So I'll just like make it. I'll just like gather them, normalize them, and make them uniform. So that is majorly the essence of doing this, so that we can be sure that our data is in the right process. So it is important for you to check all this. So you don't just assume that it is clean. If you assume it is clean and then you are supposed to be getting something, regardless, you'll be getting something else. So I hope that is clear. So I hope that is clear.
Yes, yes, it's clear.
Okay. Okay. I think I sectioned it by I want to um, I am looking for something America, America. Okay. Okay, so now I want to check for the correlation of my the correlation between my data sets, between the numerical column of my data set. I can only check the correlation between the numerical column. I can't check for for the non I mean for the categorical. Cannot check for the categorical column. So let's do this. So I am selecting the numerical column. So mind you, I am using this. I'm telling you that select all. Okay, I'm saying that all the columns. I'm saving it as a. I'm saving all the columns now as okay. Before I confuse anybody. Okay, let me print numeric columns here. So see the numeric columns. Price, area, bedrooms, blah blah blah. So I'm telling you that once in this housing data set, if the column like has the data type of int64, mind you, I already added this for 64 for like for to make it robust, and in case anybody wants to like fall back to this like code later on, that's why I included this. Because if not, since my data set here only like all of them are in 64. So I'm just like I'll just like stop at in 64. But in case you are using it in your data set, if your data set has float, so you can also use float 64 here. So is that clear? So I selected all my numerical columns here, and then I said that I want to see the correlation between. So I'm not plotting aside that I now want to see, like, I want to plot the heat map. This heat map will make it to make it visualize it. If I just plot the correlation, it will just give me just a big matrix of number. But this will make it like beautiful and make us understand. As you can see, this is showing us that they are very much correlated, and this is telling us that the so as it tends to zero, it's telling us that the correlation is weaker. Mind you, this is there is a positive correlation, there's positive correlation, there's negative correlation, and there's like there are correlation that tends to zero. This one now, okay, this, as you can see, these are positive correlation. Do we have any negative correlation? We don't have any negative correlation like that. Okay, so looking at this now, yeah, this is telling us that okay, the price of bathroom now, the price of bathroom and the price and the house, I mean the number of bathroom and the house price, they have a positive correlation. This is telling us that everything has positive correlation. We're just telling us that the and the area and bathroom have higher correlation to the price. Also, there's something called multicollinearity. Like, let me instead of rather than talk, let me just multicollinearity. Okay, let's okay. This is the multicollinearity occurs in a regression model when dependent variables are highly correlated with one another, making it difficult to isolate and interpret their individual effects on the dependent variable. So one thing if you see that you after checking the heat map, after checking this heat map, if you see that two columns are they have a very high, like very close to like, I'm not talking about their correlation with the price. Price is our target. Am I am Are we still following?
Yes, yes, we are.
Yes, we are still following.
I just want to be sure I'm not just speaking jargon. Okay. If you check the interrelationship between two columns, not the price, not like two columns, which is not the price. Yeah, I think normally I'm supposed to like draw. Sometimes we can even like drop the price column, but regardless, let's still leave the price one. So let us ignore this particular column right now. Let us focus on every other thing. So let us check the relation. Let's check the um collinearity between. I mean, let's check the correlation between area and the bedroom. Where is area? Where is bedroom? Area and bedroom. Okay, it has a low. That's a low correlation. Um, area and okay, area and bathroom. There's in this data set, there's no one that has multiple linearity, which means that there's no two. Let's look if we look at what's the ratio between bedroom and bathroom. This is bedroom. Where is the bathroom? 0.37. It is a positive correlation, but it is not multiple linearity. So multicollinearity just like kinds of tells us that um let's say we check the relationship between bedroom and bedroom, and let's say we are seeing something like 0.9, and one is our maximum value, and we are seeing something like 0.9, 0.8. We can still kind of we might say that we might decide to remove it or not. But once it is like above once it's already tending towards 0.9, that is telling us that if we check it, I will say that the correlation between bedroom and bathroom is very high. That's what we call multicollinearity, which means that um the relationship these two those two features have, like it is very similar and it is somewhat repeated. Hmm? So we might just decide to like we might look at both of them and decide to pick one of you, say that okay, since both of you are very um correlated, let us just like drop one and pick one to avoid just to make our model like work better, to avoid repetition and ah I've forgotten this vocabulary I want to use. But that's the reason why. So you check the correlation between those two, you check between different columns, not the price this time. You check the correlation between different features. Exactly.
Yes,
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 yes.
it is clear.
So depending on so I talked about bedroom and bathroom now. So depending on your particular task, let's say if depending on your particular task, now you will now be the ones to like determine that out of these two features now, which
Mhm.
one is much more important? Still, which one is much more important? Which one should I drop? Which one should I keep? That would be your own personal decision based on your knowledge um of your data set and based on your knowledge of the domain within which you are working on. Exactly. So
Yes, it is.
since we don't since there's no multicollinearity here, then we can proceed. So okay, let's draw a let's draw a histogram just to so this is showing us the data distribution. Of course, because if you check our data set, you only stories, you cannot have 1.5 story, you cannot have 2.5 story, you can only have single value, I mean real values, how do I call it now? Integer stories. Same with parking lots, bedroom and bathroom. Yeah. If we this one is not showing us the distribution of the price, and this is also showing us the distribution of the area. From the distribution of the price and the distribution of the area, what is this like? What is this telling us? Does anybody want to give it a shot?
So please, I missed this question. You just asked from.
Yeah, I said given this particular graph that we are seeing of the price and of what can we deduce from this graph?
Uh,
Hello.
so okay, is anybody saying something?
I just wanted to say like the more dense shaded part of the graph, like for example, this price is just showing that majority of the price like fall under that particular shaded portion. Like I don't know if you get what I'm saying. Same thing with the area.
Mhm. Mhm. Yeah, that's true. But how many of us were at the introduction to data science lecture? How many of us did we all watch the introduction to data science lecture? Did we watch it?
Yes, we did.
th- this
Yes, we did.
this topic, okay, we talked about this thing in yes, we talked about this stuff in what's the okay. So, okay, in the lecture, we talked about different data distribution. We talked about what's it called?
Normal distribution. Mm.
Yeah. Oh, so exactly. We talked about normal distribution, and we talked about normal distribution. I also talked about all this left skew, right skew, like when you're
Oh,
the okay.
okay.
I want
I
to I
think I
want to
understand.
quickly
Yeah, I think I understand what you're saying.
okay. I think it's this lecture. I think it's this lecture. So the thing, okay, just for the sake of time, please refer to it. I just want to use it as a reference that everything we do builds on top of each other, and your knowledge of one will like tell you what you're going. It's a kind of show you the next step you are going to do. One thing I want to okay. Let me just go back to the notes for the sake of time. This is almost now already. So I've passed. I'm going. Okay. For the sake of for linear regression now, if you'll be using it for linear regression, for you to pass in your model, to pass in to pass in this continuous variable, the best the to get so for you to be able to get an optimum result from your linear regression model, you need to if you have a data set like this, you need to like normalize it. This now, this is what we call you're right. This the two of them, they are right skewed. Most of our data points are concentrated at the left. So it is right skewed, and you can see this tail point. So this is what we are calling right skew. Same thing with here. Same with this. You can see this is the right, it is skewed to the right, and this is also skewed to the right. So what we need to do, once we see if we have a normal distribution, if we have a normal distribution, then definitely we can just proceed. But since we don't have a normal distribution, then we can just like so what the best thing to do, best approach when we have something like this, when we have a skewed data like this, is to do log transformation. There are different transformation we can do, but because of this skewness particularly. So if you can okay, let me just if you I'll just drop it in I'll drop it in the yes. So there is min, max, scalar. There is ah I forgot to know. There is min, max, scalar. I forgot. Let me check. Different is okay. So there is min, max. There is the z score. There's so there is standardization. Z score standardization. So so there are a lot of them, and you need to understand when to use it. So so this log scaling normalization is what I'll be using. So there's robust scaling normalization. So I'll need you to like read this particular aspect. So there is no one way. Hmm? As I know, as I do tell us, there is no one way to do everything. You need to like understand your data set, and then whatever your data set is telling you is will now determine the next step you're going to take. I've shown you different things now that could be done in like while building our model, but because they are not applicable they are not applicable in this they are not applicable in this solution. So I didn't use them. So for the sake of learning and for the sake of knowledge, you can read about this one. So when you are building your model, it, probably the one you are going to submit tomorrow, or the one you are going to submit later, or even and for your projects too. All these things can help you build a better model. If you will be applying for an if eventually I will advise you or some I will advise you after this after building projects here, you start participating in different hackathons. Yeah, I think that there's an hackathon by Data Science Network that's currently going on. You can participate in it. So all these things are what makes are what makes different models rank better than each other. They are what makes some models perform better at tasks than each other. So if you come if so using the right technique at the right time. Let me come back to uh, what else. So we'll be doing log transformation of puts.
Wait, sorry, I
Okay.
wanted to ask a question. Sorry.
But,
So like for the skewness, right? Like if you can look at the
mhm,
charts, sorry, if it's possible that you
mhm,
can. So this
mhm.
these that are skewed to the right, right? Like can we say
Yes.
that if we remove outliers, like I'm looking at two things now. Can we say that if we remove outliers, that might solve for the skewness, right? That's before we look at the. Like, I think log transformation is amazing, and I've opened the article, so I'll go through that too. But like, if we remove outliers, would that help? And also because it looks like it might form a normal, like a bell curve if we
Mm.
do that. I'm just saying. Then also the number of beans too that we're using for the histogram, can that affect what we are seeing too? Okay, yeah, that's
Okay.
it.
Okay. This is 50, right? Let me change the beams to 20. Let's see what is going to. But if if we are you see. So if listen one thing about outliers is that you need to be is one is to be careful when like dealing with outliers. The thing is outliers are also part of your data set. I don't just want to like just remove it. I don't just want to like remove. The thing is one thing log transformation does if you have if one thing the reason why one reason why I'm using let me explain the theory behind me using log transformation even before using even though it is skewed. Please, am I speaking too much maths? Am I speaking too much jargon? Are we still following?
Yeah, I'm following.
Yes, yes,
Please,
I'm following.
Yes, I'm
even
following. I'm
though
following.
uh one thing the log transformation does is that when we convert it to log, okay, in these numbers now you can see that the range of numbers are very large. This is from this is two exponential, so which is like maybe like from 200, maybe
Like
200,000 or
20,
something. Let's say
like
2 million.
20 million or
uh
so.
let's say from 20 million. Okay, that's it from 20 million to like this is like 1.2 billion. Do you get 1.2 billion? And this is already like 1.3 something billion. You see, like the range is very wide. Hmm? One thing dog transformation helps us do is that it collapses the numbers. All I said, it reduces this wide range that we are having within our target. I mean within this price now. Our same that's also happening within our area. It's it reduces it. So you can so when you do a lot of transformation, you can be having something between probably like maybe 10 to 50 or 10 to 20. Do you get? So all the gap that we are feeling with these outliers, it helps us to, like, reduce that gap. Ah, okay, let me go to let me see what these people let me see how these people explained log transformation. So we said oh, exactly. Look at it. See, log scaling normalization. Log scaling normalization converts data into a logarithm scale by taking the log of each data point. It is particularly useful when dealing with data that spans several orders of magnitude. So this normalization comes in handy with data that follows an exponential growth or decay pattern. It compresses this exactly. It compresses the scale of the data set, making it easier for models to capture patterns and relationship in the data. So that's this exactly is what I'm trying to explain. So it makes once that's what log transformation does. It helps you to reduce the scale of the data set while still maintaining the original feature of the data set. So with log transformation now, you don't need to get rid of the outlier. Isn't it because it's an outlier? Because the price of a house is an outlier doesn't mean the price is wrong. Do you get? It doesn't mean that data set is wrong. Your model can actually learn something from it. But even if I just use the data set like this, if I just use the data set like that, um my model, this is a linear regression. The scale is very wide, and it will struggle to converge. So when I reduce the scale, to very small, to a range of very small numbers, it's able to learn properly. And then when I want to run my prediction, I do the inverse of the logarithm, and then I get my prediction. Please, does that make any sense at all?
Yeah, it does. It makes a lot of sense. I want to ask a question too, though. Sorry, that I'm
I also have a question to
yeah.
No
So
problem, no problem.
it makes a lot of sense. I get what you're saying. The machine learning models learn better from larger values than small values. So you want to bring them into similar range, in a similar scale. So that's fine. But now,
No, no, no,
the
no, no. Machine learning, especially I'm talking especially for linear regression now. They
okay,
learn like for when they learn when the numbers have a lower scale compared to larger scale, which is why we are using which is why we are using the logarithm to get like the logarithm will scale it down to probably you'll be see when we do the log scale, you'll be seeing numbers like instead of all these 200 to 20 million that we are seeing, you'll be seeing numbers like 14, you'll be seeing numbers like 16 in that column. So that's basically what the log transformation does. So okay, continue.
so what I wanted to say is like they both. So I will still read this article. I've already opened it and bookmarked it, so I will read it. But like,
Mm-hmm.
because of that, was now because the other normalization methods too, they serve the same purpose. So like, was now the like standard scalar does the same thing, min max scalar. I understand the approach, the method is different, how they normalize is different, but like, why do we like, is it because for log normalization, is it because the distribution of those columns are not normal, like they are skewed to the right. Is that why log normalization will be better than min max and standard scalar? That's what I just want to know.
Okay. Okay. I'll answer that. So who said they wanted to ask a
Yeah,
question now?
yeah. So similar to my question is kind of similar to what he just asked right now.
Okay.
So this log, firstly, I just want to clarify this log. What do we call it?
Transformation. Log
Transformation.
transformation.
Yeah. So it's just a way
Mm-hmm.
to like because because our data is skewed. So it's just a way to
Mm-hmm.
get it like in the right shape before you do the whole modeling. Yeah. I just want to confirm.
Exactly. Yes,
Now,
yes, yes, yes.
so the reason for using this log transformation is it because the data is right skewed, or you can also use it for like left skewed, like because I know that there are like maybe other ones also. I don't know if you get what I'm saying.
Mm-hmm. Mm-hmm. Yeah. Okay. The major. Okay. Thanks so much for your questions. The major reason why I am choosing log transformation is because of the skewness. It's because it's right skewed. If it is not right skewed, if it's not right skewed, if it's a normal distribution, I will still like the scale of the data set is very large. So I will now check through depending on my data set. So once okay, I will just like you can just like keep it at the back of your mind as a rule of thumb. If your data set now, if your data set is skewed, if it is skewed to the right or to the left, just and you are and it has a large scale, just I think you should just like use log transformation. But if it is not skewed, if it is not skewed or the skewness is not like that stuff, so you can use a min max scaling. You can actually use any of these, and then check whichever you can read through each of these use case now. Read through it and understand it. So and or when you see your data sets, you can have this kind of website. You can have it probably bookmarked somewhere, and then you can come. Okay, what is my data set saying? What is this? Okay, let's see. It's called normal. It transform. See this one. Look, min max scaling now. It transforms our data set from to have like so a specific range, typically between 0 and 1. What it is also doing is that it's also help us to reduce the scale of our data sets. Exactly. So okay, let's look at when it's okay. Min-max scaling is a good choice when the appropriate upper bound and upper bound of data set is known and data set has few or no outliers. When you don't have outliers, you can use your min-max scaling. And if you also another way is that okay, like Izu said earlier, if we decide to get rid of if we decide to just drop those outliers and we just like so we if we decide to just drop those outliers, we can just like use minimax scaling directly. But why drop it when there is an other algorithm that can accommodate it? Do you get what I'm saying?
Yes, yes,
Yes.
it makes sense. So you don't have to lose the data, more data, better. More.
Exactly.
Yeah.
You don't have to lose those features. Those features will also help you. Those features, there's a specific how will I call it? There's a specific representation that those data are bringing to your model. So dropping get see, the last see before dropping anything, dropping a row, dropping a column, dropping anything should always be the last thing on your mind. If there's no other thing that works, then you can decide to like drop. But before you drop, try other methods. Try other methods and see what works. If there are other methods that work, try them out. If your model is still not performing woefully and you've tried everything, then you can now try dropping them and check your model performance. Then if there's still no change in your model performance, then you probably know that okay, probably that is not that is not the cause of or whatever you are facing or whatever issue you are facing in your data set. Do we get that? So, do we get that?
Yes.
Yes, yes, yes,
So
yes.
don't be quick to drop. Don't be quick to drop. Even in if you are if you even if you have outliers, there are other advanced machine learning algorithms that can accommodate outliers. That's like that can make room for outliers. So we'll go into that starting as from tomorrow. So we'll go into all those kind of algorithms that can accommodate, that can even that's they can make room for outliers. So before you say you want to drop an outlier, let it be your last resort. Let it be the last resort. Before like dropping anything, let it be the last resort. Exactly. Okay.
Yes,
Look, okay,
yes.
look, okay. So now, so let us just go back. Can we proceed now? I hope this is clear now.
Yes, yes,
Okay. So um this is me performing exploratory data analysis and seeing what is exactly going on in my data. So this is me doing investigative journalism. So you need to, before you say you want to build a machine learning algorithm, you need to understand this, you need to know what exactly is going on and push for that. So this is the distribution of the house price. Okay. This is the report, and this is the box plot. As you can see, of course, they are outlier. They are outliers. I think I didn't do the box plot of the report. I forgot to do that. You can go and do that in your what's it called, when you receive the data set. When you receive
Hello?
this notebook. What is that? Please mute
Hello?
yourself.
Yeah. Um,
Okay. Oh, okay.
I wanted to ask something. My network was cracking up before. What you showed now,
Okay.
is it still before the transformation?
This one.
Yeah, is it?
Yeah, we have not transformed it yet. We have not
Okay,
transformed
okay,
it.
okay, okay.
We
Yeah,
have not
because
transformed. This is still
I couldn't see anything on my screen for like a while. That was how I'm asking. Thank you.
okay. We haven't done the transform. We haven't done the transformation. This is still. So now I decided to like see what is going on in my data set. So okay. This is the number of houses by main road, number of houses by guest room. So this is just me plotting. I expect you. I know I plotted everything together, but you can plot them up. But I don't want to be plotting everything one after the other. So I just like plot them once and for all. Same thing with. Okay, oh, okay. All right. I thought I didn't do the box plots, but so this is also the box plots and showing us. As you can see, they are outliers. But regardless, we move on. Yeah. Okay. Now, oh my, this is already 9:18. Let me try to rush through this as fast as I can. If I am too fast, call my attention and we can see all the. So, have you seen this plot before? Have you seen this plot before?
Yeah, yeah, I've seen it.
No, explanation is very detailed though.
I have not seen this one
Okay,
before.
okay, okay. This is just like this. Okay, this is a peer plot. So we are just like plotting. I'm plotting the pair plot is only select the numerical, so it selects the numerical values. So this is just me like plotting all the values against each other. So and just this is just, so this is just me you might not necessarily plus this, but it's just a means of quick quick investigation. Okay, what is the interrelationship? I can As you can see, the plots we had earlier between price and area that was up. I think it is already far above. I don't I Laptop seems to be
It's like
hanging.
similar
I don't know what's
to
wrong.
it's like similar to heat map, but instead of
Uh,
the values, we are
mhm.
showing the chart
We are
itself.
showing we are showing different charts of so you see the
So
chart of
what's this one called? It
this is
looks
called is peer plots.
beautiful. Peer
It's
plots.
peer
So it takes all
Oh,
the
okay.
numerical, let me call
He's
it
showing
data
it
or
individually, I think, like one after the other.
so it
so
will
doesn't
look okay, look, calm down, hold on. This is
okay.
parking, right? This is parking.
Yes.
This is you see. This is so it is to showing us parking against price. So this is parking on the y-axis, price on the x-axis. So parking against price, parking against area, parking against bedroom, parking against bathroom, parking against number of stories. Do you get? So we
Yeah,
have
I
all
get it.
of this on the x-axis. We also have the same thing on the y-axis. So it's just like plotting them against each other. So it's just a means of showing it helps you to like quickly understand what exactly is going on in your data, and because so from here I can see that okay, area and this I can see that this is area. So what is on the x-axis here? I can come and check price. Oh, area and price have a positive positive relation, have a positive correlation to each other. So this is just a means. I also wanted you to notice. So you can it's just a quick summary. As the same way we have the just described. So you can always have this. We are using Seaborn. We are using Seaborn library. So you can use it to do a K plus and to generate all this for. If you now need a bit of, but remember, see, I'm using this. I'm using my U is furnishing state. I can change, so it is all this part you can see it is highlighting the furnished, semi-furnished, and unfurnished part. I can instead of this EU, instead of this furnishing status, I can use I can use another categorical variable here. So you can always experiment with that. I use furnished. I use furnishing status. Which other categorical variable do we have in this data set? Okay, you can try that out when you get when I send this to you. So okay,
Sorry, can
and
I
this
I want to ask a question now. From this pair plots now, it's obvious
mm-hmm,
that some okay. Let me not say that it's obvious. Okay. Sorry, my bad. What I wanted to say is from the chart, yeah, some of them are
mm-hmm.
not. It's like there's no correlation between some of the features and the price. But I just saw now that the reason why they look like this is because they are discrete values, like bedroom, bathroom. Yes.
Exactly.
Yeah. But like
Mhm.
if we did this and on some other continuous values and there was no correlation at all, is it safe to drop those features?
The thing is, I won't say the first thing you should do is not to drop at the beginning. There as in this coming week, you will learn what we call feature importance. There are algorithms that let you do feature importance. So when you train your model on, when you train your model on them, it will show you, it will rank those features, and you see that okay, when you see that it has little correlation, it is that's not, you can don't drop it at that point yet. First of all, build the machine, build the with you do tell you this thing is a iterative process. You keep trying different things. It's a iterative process. So after building it, then you now check the feature importance. You'll learn about it in this coming week. So when you now when you check the feature importance, you now say, okay, this thing is very, very low. It is not contributing at all to my model. So I can, or the contribution is, is negligible. Then you can now decide to what? Drop it. Exactly. If you just keep, okay, keep suspecting. So if you now gather all the evidence together, like, oh, Alaye, this arrangement is not going to work, then we stop that. Exactly.
Yes, yes, boss. Yes.
Yeah, so now look at this particular cell. This is the cell where we apply log transformation. So I only want to perform log transformation on two columns, price and area. So the columns I want to transform to I want to convert to log transformation. So yeah, and then I perform log transformation. Look at what price is giving me. Okay, let's go back to what was the for. Let's go back for what was price, and this is 30, let's say this is 13.3, about 133. Is this 133 or 13.3 million? 13, I think this is 13.3, right? And this is 7420. Somebody should please hold that 13.3 million, 13.3 million and 7420. Instead of 13.3 million, see what you have, 16.4. Instead of 7,420, we're having what? 8.9. You see how it was able to, do you see how it's able to like do that? Just by computing the log. So okay, let me also do let me do a box. I want to plot the histogram again.
Yeah, I was going to say that too. You should plot the histogram. So yeah, yeah.
So we're using pins as 15 and okay, okay, let's do this. Let me do same for, can you see?
Let's say,
Can you see that? So
yeah, it's a bell curve proper.
exactly. So we are having a proper bell curve. So let me do same for area.
For area, yeah, for area too. Oh, that's cool.
So
Yes, it's cool. So it's better.
perfect.
Yeah.
So we now have a normal distribution. So I hope so now look at this. It's not see, look at the range now. See, it is ranging from see around this is like let's say 14.25, let's say almost 14.25 to what? You see how it's no more outlier. See that we don't have any more outlier. You can say that okay, maybe 16.5. Let's say we have from 14.25 to 16.5. See how it shrank everything together. So with this now, we can see that it has taken care of our outlier. So we don't necessarily need to get rid of any outlier. Do we get that?
Yes, yes, yes.
Yes, yes.
So and we can see our distribution is normal. So now that we are done that. So now I want to one out encode our variable. I hope we all understand. We all understand the concepts behind one out encoding. No? Do we all understand the concepts behind one out encoding?
Sure,
You're trying to
sure.
change. Yeah. Yes, yeah.
Yes, yes, yes.
Okay. So and okay, now mind you, or if you look, one thing I just want you to note is that okay, um, look at this. Look at if you look at this if you look at this, you can see main road yes, but you cannot see main road no. Yeah, I can see guest room yes, you cannot see guest room no. You can see basement yes, you cannot see basement no. Why is that? Does anybody know why?
Yeah, like one hot encoding now, it would those unique or discrete values, right? They would they will have their own columns or they become their own features. So wherever you had yes before, it will be one. Then wherever you had no before, it will take the like it will be one on the other column, something like that. So it's like 1 0 1 0 1 off, like something like that. I don't know if my explanation is clear, but yeah.
Yeah. That's basically the reason why. Okay, I specified that is the okay. Let me take us through this first of all. Okay. Who is watching movie behind the scene? Who is that watching movie? You cannot
I'm
Sorry,
not
even
the one
invite me
sorry.
to
watching.
come and watch it.
I
I'm
wanted
not
to
the one
ask.
watching movie. I don't know how my mic on. It's my little one's watching. This. Don't mind me.
Uh, ex-
Actually,
Excuse
fine.
me. When is this lecture meant to end, please?
Sorry, it's supposed to end by 9.
Oh,
I'll just finish up this code, and I don't know if anybody has any other issue. Is there anybody? If anybody has any other stuff, you can just okay. You can just reach out to me. I will make the slide is available. This notebook. I'll also send it to the group if anybody's interested. So okay, look at this now. So I said that colon equals to categorical, right? But see, I am saying um it's still one of them could but see I'm not it is not in numbers. I need it as numbers. So so I just tell you that okay, I need the data type as what? Integer. So it will do that. So now let's now come back to this main road, no, main road, yes. Mind if I'm saying one, yeah, I'm telling this one that this means automatically this one is 0. So I'm saying 1, automatically this one is 0. So it's just like a repetition of information. So if there's main road no and there's main road yes. So if I just say main, if I just pick main road yes, if I, anywhere there is one, it is telling you that that's the main road, yes. If I now have zero, it will just infer that okay, that is main road, no. So instead of repetition of information, I can just like drop this or drop all those other ones and just keep one. So I can just drop one and then keep the rest. Same thing with this. Look at this furnished for furnishing status finish. So this one too. If it doesn't if it says one, if it says one, it means uh if it says one, it says that it's absent in others. If it says 00, hmm? If it says zeros, if it says 10, it means that okay. Let me go. Don't let me be faster than my mouth. If it says 10, that means we can only have one occurrence at a time. If I have 101 here, that means others are absent. If I say that means others are absent. If I have, so let's say I dropped this one now. Let's say I dropped this particular column. If I have 10, if I have 01, if I now have 00, hmm, what does that mean? It means it is this third one that is present. Do we get that, or should I come again?
Come again, please. Yes, sir. Okay.
Um, I'm explaining the concepts behind this drop force equals true. The reason why I'm using this drop force equals true. If you are this particular aspect, if I say if I don't if that's if I'm talking if I don't like specify drop force equals true, it means that I am repeating this information. There's repetition of information. Same thing that applies. Do you understand when I was using this yes and no as an example?
Yeah.
Yeah.
So it's telling so if I drop this one, now, it's telling that if I have one, this one is absent. If I have zero, it's telling that okay, since this is zero, then this it is absent. So then that means it is this one that is present. Automatically, it's just telling me that if this is not yes, then this is no. So now let us come to this particular one. So if I'm doing 10, that means that this one is absent. If I'm doing 01, that means this one is also absent. But if I now have 00, that means both of these two are absent. Then that means it is this third one that is present. Does that make any sense at all?
Yes, it
Just
does.
the same
Oh, okay,
logic.
okay, yeah, yeah. Yeah, I
Yeah, yeah, yeah,
understand.
yeah, yeah, I
Is
know.
Just the same
semi-finished,
logic.
finished, and unfinished. Okay, yeah,
Exactly.
yeah.
So that's why I just like drop force equals true. So I just drop one of each of those stuff, and then instead of repetition of column, instead of you can say I can just have main road yes, guest room yes, basement yes, like this yes yes, and then I'll just have furnished and unfurnished. Then okay, this is semi-furnished and unfurnished. That means like furnished, that means when I have okay, see now, that means when I have 00, that means it is what? Furnished is what? One.
One.
Furnished that is not present here is one. So it takes note of that. So you don't need to specify it again here. So exactly. Then this is here this thing I want to split my data sets to train and test. Since we've already one not encoded my data sets, I can now like split it. What what's wrong? Oh, okay. I've not imported train test bits. Circuit length. Okay. Mhm. So then run this. So here I just select every other column except the price column, and then I dedicate the price column to my Y. And then yeah. So after splitting the data set and getting the data set, linear regression So I first of all, so I defined my linear regression. I established my linear regression. Then I fit the model. So these are just the coefficients. So now these are the coefficients, and these are the W's of our data sets, and these are the D of our data sets. So linear regression. So I fit the linear regression model on. So this is it. That will predict. So then after we do the prediction, they will now evaluate the error. This is the error we got. This one. X has one feature. Question is switching to- Okay. Oh, this is an error. Okay. Regardless, hope we all understood this up to this aspect. So we can see this is the mean square error. Do you understand everything that I did here?
Yeah. Does that mean
Yeah,
square
of
error
course.
not too much like that? Or we have
Yeah, I
No,
to
get
no,
it.
no, no, no,
titrate
no,
further?
no. No, the thing is, though this means square root looks a much, so looks a bit much. That's why sometimes we use root mean square error, so that this number will not like look so big. We also do root mean square error, which is just taking the square root of this number. But this is actually this is nice. Our model is working nice right now. So that's about building a linear regression model. So this is already an expo for all of you guys that have not done your assessment. You can use this to work on your assessment. But now let me I won't take much. I won't take time on this logistic regression. I've taken my time. Okay, yeah, I didn't even prepare much for this quiz here. So there's no time to do what's it called? Exploration data analysis in this part. So yeah, we have three targets. Hmm? We have three targets. Logistic regression. We have iris. So our iris can either be a um Setosa species, versicolor species, or a virginica species. So same. But remember, since we are not, there's no these numbers are small. This is sepal length, sepal width. They are small numbers, so they don't need to be normalized or standardized. So if you can just use them as they are small numbers. And since our target suit, it is a categorical variable, so there's no, we don't need to do any transformation on this particular data set. So let me run it. Then okay. Oh, really, also this one. Okay. Okay, we still use scalar here, but that's nothing spoil. But necessarily we don't necessarily need scalar because the stuff is the numbers are very small. Okay, now look here. we did logistic regression. So there for logistic regression and for linear regression, since we are predicting different types of variable. For logistic regression, we are predicting number, we are predicting category, and for linear regression, we are predicting um continuous variable. So
Like number.
yeah, continuous, yeah, numbers. So the method of what's it called? Method of evaluation will be different from each other. So see the here for logistic regression we can use accuracy, precision, and stuff like that. For what's it called? For the linear regression, remember we're using um root mean squared error, root mean, or you can use the root mean square, that's the mean absolute error. So here we can use the accuracy. So now we'll see, okay, how well is our model performing on trained data and also test data. So this is so after fitting it, then we check the accuracy. So after checking for the accuracy, we now want to see there's something we now want to check for. There's something we call confusion matrix. Confusion. This is what we call confusion matrix. It is a matrix that helps you to like understand how your model is performing and know which section it is predicting correctly and which one it is predicting wrongly. So this column in the middle, this is okay. This you can see this is predicted column. This is the true column. This is the true column. This is the predicted column. So it is so 11 species of this setosa. So all the 11 species were correctly correct. So were correctly predicted as setosa. So that's what we call what we call that true positive. So this one also 11 species of versicolor were correctly predicted as versicolor. That's also true positive. But okay, two versicolor were wrongly predicted as Virginia. What do we call that? That
False
is
positive. Is that false positive? True positive.
no, it is
No,
not
that's
true positive.
false positive. False
So
positive.
it is it's not okay. It is versicolor. It is predicted as a it is wrongly predicted as a vaginica. That is what we call it is a false negative. Hmm? That's what we call false negative. I think the concept of false negative and true positive and false positive, false negative and true negative. This is a multi-class label. So it might be confusing here, but I think you can see it and see people are already dropping off the course. I think we should just like end it here. You can read about. I just wanted to show us like the confusion matrix, how it works, and so the slide is also there, and you can also, I think we've always dropped links to this slide. Go through this note. I will drop the link to this particular notebook. You can go through it, and if anybody has any question, then so I think yeah, thanks so much for waiting to this time. I didn't know I didn't know I will stay this long. Thanks so much for waiting behind.
Thank
Um,
you, Yamife. So
yes,
insightful.
sorry
Thank you
for
very
taking your
much.
time. All right.
I
So
didn't know.
okay, don't forget to turn in your assessments and yeah,
Yeah, I'll try to do that this
by
time.
I guess there's been a lot of review that has passed that has. So have a wonderful weekend, everybody.
Yes, bless you,
I
sir. Thank
too
you.
have a good weekend
Yeah, it's bye
and a
bye.
good Sunday. Yeah, bye.